going to do some exercises on proofs. Right, exercise 1. Question 1. Prove the following statement. For any integer value of x, fx equals 2x squared plus 2x plus 3 is odd. Well, to solve this problem, let's write down fx. So f of x is 2x squared plus 2x plus 3. I'm going to split that 3 into 2x squared plus 2x plus 2 plus 1. Now that gave me the opportunity to take out 2 common factor here. So I get x squared plus x plus 1 plus 1. Now remember that we know that for any integer value of x, but now let's let x squared plus x plus 1 equals p, where, so we have to write that, where p is an integer. Therefore, I get 2p plus 1, which is the definition of odd number. So, things to note in this case would be even number will always be 2n, and odd number will be 2n plus 1. Question 2. We're meant to disprove the following statement. And the statement is x cubed is greater than x, comma, when x is not equal to 0. So this is the statement, and we need to disprove that. In this case, let's try if x cubed is less or equal to x, then the statement is false. And so we need to find any condition, any one condition where x cubed is less or equal to x. So we need to try let x say equals to minus 2. So if we substitute minus 2 into x, we would get minus 2 cubed less or equal to minus 2. Minus 2 cubed is minus 2 times minus 2, which is plus 4. 4 times minus 2 is minus 8. So that's minus 8 less or equal to minus 2. Well, minus 8 is not equal to minus 2, but minus 8 is less than minus 2. Therefore, the statement is false. Question 3. We need to prove that a to the power of m times n to the power of n is equal to a to the power of m plus n for all positive integers m and n. Okay, to prove this, we need to write down what a to the power of m is. A to the power of m is a times a times a times dot 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 times a. So that is written as m lots of a multiple or multiplied together. Right, so that's what that is. And we need to write down a to the power of n, and that will be again a times a times a times dot 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 times a for n lots of a multiplied together. Now, if we then bring them together, so if we have a to the power of m times a to the power of n, what that would be taking the a to the power of m, which is what I'm going to write here, and I'm going to times that by the a to the power of n, which is what I'm going to write here. And so you can see a to the power of m is a times a times a times dot 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 times a, and the a to the power of n is a times a times a times dot 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 times a, and all multiply together as the product. And so what do we say this is? Well, that would be the so that would be the m plus n lots of a multiplied together. So how do we do that? So if we count 1, 2, 3, 4, 5, 6, so we can count the number of a's there, which is lots of m, plus the number of a, that's lots of n, and so that will become a to the power of m plus n. And so therefore a to the power of m times a to the power of n is equal to a to the power of n plus n.